Assalamu alaikum, dear 9th class students. In today's lecture, we will discuss the book page number 9 to page number 13. After that, in the next video, we will discuss the exercise 1.3. In today's lecture, the basic topic is addition and subtraction of matrices. Let's suppose we have any two matrices A and B. When will be its addition possible? There are two conditions for this. The entries of the both matrices will be real. It means that the entries of the matrices would be taken from the real numbers. And as you all know, that real numbers are all the numbers, including rational and irrational. But the complex numbers wouldn't be included because they are saying the entries will be real numbers. What would be the second condition? The most important condition. The true matrices, means both A and B matrices, would be of the same order. Yeah, it's very noticeable that if A is a 2 cross 2 matrix and B is 1 cross 1 matrix, then their addition or subtraction is impossible. In addition and subtraction, both of the cases needs these both conditions. The first condition is the entries of both matrices will be real numbers, and the second condition is the order of both the matrices would be same. For example, if A equals to 230,106 and B is equal to -234,123, then you can see that both the matrices have same number of rows 1, 2, 1, 2, and both the matrices have same number of columns 1, 2, 3. Same like this 1, 2, 3. 2 by 3 matrix. Both the matrices are 2 by 3 matrices. So we can add them. A plus B. All the entire entries would be added. 2 is going to be added with this -2. 3 is going to be added with this 3. 0 is going to be added with 4. 1 is going to be added with 1, and so does all. This is done. So we can simply write here as 2 minus 2, 0, 3 plus 3, 6, 4, 2, 2, 6 plus 3, 9. Okay. So this is the A plus B matrix. Now we are going towards the negative, or we can say the subtraction of matrices, A minus B. If I am going to take A as this matrix and B as this matrix, then what would be the negative of both of the matrices? If we are going to subtract these matrices, then what would be the answer? 2 minus 2, 3 minus 3, 0 minus 4, 1 minus 1, 0 minus 2, 6 minus 3. And the answer would be 2. Minus and minus, both when multiplied, gives plus. 3 minus 3, 0, and minus 4. Here 1 minus 1 is 0. Here 0 minus 2 would be minus 2. 6 minus 3 is 3. So A minus B, the answer of A minus B is 2 plus 2, 4. 0 minus 4. 0 minus 2, 3. Okay. So that's what I done for addition and subtraction. Now let's take another example. Example number 2. If A equals to 1, 0, 2, 2 minus 1, 5, 7, 3, 1, and B equals to 0, 1, 5, I am going column wise, 3 minus 1, minus 2, 4, 2, 7. Okay, so addition of both the matrices. The addition never changes the sign, but the subtraction does. मेरी बात का मतलब है कि एडिशन की वजह से कभी भी नंबर्स के साइन चेंज नहीं होते जब हम एडिशन कर रहे होते, लेकिन सब्ट्रैक्शन दूसरे नंबर का साइन चेंज कर देता है. सब्ट्रैक्शन चेंजेस द साइन ऑफ द सेकंड नंबर. फॉर एग्जांपल 1 minus 0, 1 plus 0 makes 1, 2 plus 3 makes 5, 7 plus 4 makes what? 7, 8, 9, 10, 11. 0 plus 1, 1, minus 1 plus minus 1. We'll discuss it later. 3 plus 2 is 5. 2 plus 5 is 7. 5 minus 2. 1 plus 7 is 8. 1, 5, 11. 1, 5, 8, 7. Minus 1, and I am going to clear it. Minus 1 plus minus 1. Whenever plus is multiplied by minus, the answer would be minus. Here is the bracket. Bracket means that plus and minus signs are both multiplying with each other. So plus minus would be minus. And minus 1 and minus 1 both will make what? Minus 2. Okay? So the answer of this would be minus 2. 5 minus 2 is 3. So we have done the addition of the matrices. Now we have the subtraction. Yes, we are going to do the subtraction now. A minus B. What was A? 1, 2, 7. 0 minus 1, 3. 2, 5, 1. This is our A. We're going to write minus here. And what is B? 0, 1, 5. 3 minus 1 minus 2. 4, 2, 7. This is our second matrix. Okay. So 1 minus 0. 2 minus 3. 7 minus 4. 0 minus 1. minus 1, minus 1, 3 minus 2, 2 minus 5, 5 minus 2, 1 minus 7. All done. Okay. So here we can write it as 1 minus 0, always 1. 2 minus 3. Here you can see that if you have no sign, then it means the number have a positive sign. Positive and negative means we are subtracting it. So 3 minus 2 is 1. And what would be the sign here with 1? With 1 we will write minus, because we will look at the greater number, the big number. The sign which appears with the big number would be written with the number as an answer. Okay, 7 minus 4 is 3 minus 1. Here it is, let's explain it. Minus when multiplied with minus always gives plus. So here you can see that minus, here you can see that this minus is multiplying with this minus, so the answer would be plus 1, and the whole answer is 0. Okay, here I'm going to write it. 3 minus 2 is 1. 2 minus 5. 5, the 2 is appearing with positive sign and 5 is with negative sign. So 5 minus 2 is plus minus minus, 5 minus 2 is 3, and we will write the sign which is with the big number, so it's minus. 5 minus minus plus 2. Okay, 5 plus 2 is 7, and minus 7 is 6, and negative sign would be written. So this is the answer of the A minus B. Okay, so in the end it is written that the order, note that the order of a matrix is unchanged under the operation of matrix addition and matrix subtraction. It means that if the order is not same at the start of the question, then you cannot change the order in between. For example, if A is 2 cross 3 matrix and B is 1 cross 2 matrix, or else like A is 2 cross 2 and B is 1 cross 1, then you are not supposed to change the order. You cannot be able to change the order during the operation of addition and subtraction. Nothing else. This is quite simple. Okay, then it comes to multiplication of a matrix by a real number. How are you going to multiply the matrix with any real number? Multiplication. Okay, we are going to cover it quite fast. Let A be any matrix and the real number k be a scalar, then the scalar multiplication of a matrix A with k is obtained by multiplying each entry of matrix A with k. It is denoted by ka. It means that with the scalar multiplication, the order do not changes. What is the scalar? Scalar means any number, 2, 3, 5, 7, 11, 100, 1000. If this type of any number is multiplied with a matrix, for example, this is a matrix A and I am going to multiply it, the whole matrix, with 2. So it would be the unchanged, means the order would not is not going to be changed. Okay, with the scalar multiplication the order remains the same, it doesn't change. Let's suppose I'm going to take a counter example. A equals to AB CD. Okay, now I'm going to multiply it with 2A. So 2A means multiplying every single entry with 2. 2A, 2B, 2C and 2D. So you can see that order was here 2 cross 2 and it remains the same here. It doesn't make difference. Okay. Then the commutative and associative laws. Yeah, commutative and associative laws, we are going to discuss it. Commutative and associative laws for addition of matrices. Okay, basically the commutative law is like this: a plus b gives b plus a. In matrix addition, you cannot write the notations like this. In the very early video, I have told you that in the matrix are denoted by capital letters. So it would be like this. It means that if you have any two matrices, yeah, it's about the order. The order is first priority. Order of matrices under consideration will be same. Both same. This is the first priority in the addition, in the subtraction, in the commutative and associative laws of addition. Of course, the orders remains the same for both the matrices, both or three or four, how many of matrices you are discussing, all of the matrices have the order must be the same. So commutative law holds like if you are adding two matrices here in this order, that first is written, A is written here and B is here, then if you change, you write B here and A here and you add them, the answer of both cases would be same. What about the associative? Let me tell you about the associative law. In normal, we use associative law like this. Just the brackets changes. This is the associative law in actual. So in matrices, you can write it as मैंने तो ये वाला इधर लिख दिया और ये वाला इधर लिख दिया. It was a big mistake. बुक में तो ऐसा नहीं लिखा हुआ. No, when the equality appears, it doesn't make difference if you write this here and that here. Both are equal. The law is telling us that these are equal. So it doesn't matter if you write this one here and this one here. It's okay. Okay? So this is the associative law. Now we are going to discuss it with a counter example. But I will take our 2 cross 2 matrix because 3 cross 3 is a little bit harder to do. Let's take A plus B. I am considering A as 2, 1, minus 3, 0. And B is A, B, C, D. Now I am adding both of them. The answer would be 2 plus A, 1 plus B, minus 3 plus C, and 0 plus D. Okay? And if I add B plus A, B, C, D, 2, 1, minus 3, 0, the answer would be A plus 2, B plus 1, C minus 3, D plus 0. So you can see both of them are same. And if someone object that here 2 plus A is written and there A plus 2 is written, they makes difference. No, they doesn't make difference because 2 plus 1 and 1 plus 2 always makes the same answer. Okay? So these are both the same. Now I'm going to take some example for what? For associative law. Or you can do it by yourself. Let's discuss the identity and inverses of a matrix. Additive identity. Yeah. Basically, when we discuss about the identity,